until he had like help. And so I walked out and he was like covered in slime, the kitchen, everything. I did. It's not that, it's 8 laps, you know. He's 9. Look, you gotta pick something they hate or else, you know. Tell me what? Tell me. Anyway. And then Miss Gibson was there, Mr. Gibson was there, so they all saw me making him run. And I'm sure they thought I was making him like run for fitness, but it was for punishment, and he deserved it. Yep. All right, so first semester, we learned a lot about derivatives. You remember this? Okay, second semester is all antiderivatives. So it's the opposite. No, you can't drop, it's too late. Ha. Okay, so an antiderivative is the opposite of a derivative. So we're going to be basically undoing all the stuff that we learned in the fall. Yeah, it's not so bad. Okay, so capital F is an antiderivative of little f, if and only if, hopefully we remember that, if and only if. Okay, 2 things have to be true. If you have capital F and you take the derivative, you should get normal f. And you're going to learn some new little symbols. That. Now, we'll go through what all that means in a second. Okay, but capital F, when you take the derivative, you're going to get normal f. That's what an antiderivative is. Okay, now, the little squiggly s symbol, this is an integral. And it's kind of like the d dx for derivatives, okay, but it's for integrals. Okay, then this in here is called the integrand. And it's whatever the function is that you're taking the integral of. Okay, and then the d dx, or I'm sorry, the dx here at the end means with respect to x. With respect to x. So when you did d dx, it was the derivative with respect to x. Now if it's integral dx, that's the antiderivative with respect to x. Okay? Now, just to kind of run you through some notation things here. Okay, capital F of x. When I take the derivative of that, I get normal f of x. What would I get if I took the derivative of that? You already know this. F prime. And what about if I took the derivative of that again? F double prime. So when I take derivatives, I would go down that list. Then when I do an antiderivative, I would be going up that list. So this is what I mean by that. If I have f double prime, what's the antiderivative? F prime. Then the antiderivative of that would be f. Then the antiderivative of that would be capital F. What'd you say? Very clean, yes. Very clean. Okay? Antiderivative. Now, there are a couple of other notations that I just want to remind you of briefly. So let's say that I had dy dx. What is that the same as out of this list? What is dy dx? It's an f prime. So if dy dx is here, what would the derivative of that be? You remember? D squared y dx squared. So if I took the antiderivative of d squared y dx squared, what would I get? Dy dx, right? Now, if dy dx is f prime, what is the antiderivative of f prime? It would be f or y. Very good. So if you have y, the derivative is dy dx. Second derivative is d squared y dx squared. Now, you will not normally see that somebody will go from y to a capital Y. That's weird. You could see it, but it's very unlikely. So usually in this notation, you'll start with one of these and be going up to y. Okay? So, we're going to do a little bit more talking, then we'll do some examples. So, capital F of x is the general solution for a family of functions that all have the same derivative, f of x. Okay, f of x is the general solution for a family of functions that all have the same derivative, f of x. Now, you could be thinking, okay, well, how is it possible that a bunch of functions will all have the same derivative? Okay, this is how it happens. Think about 3x squared plus 4, 3x squared plus 8, 3x squared minus 3,642, and 3x squared minus 10, whatever. Okay, what do all of those functions have as their derivative? 6x. Now, how did all their derivatives come out the same? Well, think about what happens to this constant no matter what it is. Derivative is 0 and it goes away. So they all have the same derivative of 6x. All of them have that derivative. So instead of having a bunch of different numbers, you would write it like this. Capital F of x equals 3x squared plus c. Where c can be any constant, because when you take the derivative of that constant, it's going to go away and it's going to give you the same derivative no matter what that constant was. Does that make sense? So this is called the constant of integration. And usually you're not going to know what that constant is, because when you take the derivative, it goes away, whatever, it's done. Okay, now, this is called the general solution. Okay? Alright, now we're going to get into some examples when you're ready. I'm going to turn the page. Okay, let's just briefly review. Do you remember how to take derivatives? Yeah, so what do I do with the exponent? I times it down, then I minus 1, yeah? So I want you to think about doing that backwards. Can I turn it? We good? Okay, if I wanted to do that backwards, instead of taking away 1 from the power, I'm going to add 1. So if you want the integral, this is going to be the power rule, if you want to label it in your notes, of x to the n dx, you are going to add 1 to the power. So instead of being x to the n, it's going to be x to the n plus 1. And then, instead of multiplying the number down to the front, you're going to divide by that new number. So it'll be 1 over n plus 1. Then anytime you take an antiderivative, you're going to put a plus c on the end. Now, we're going to do a couple. Yep.
Why is it divide by 1? Or put it over, under 1?
Because you're undoing when you times the number down. And I'll show you some examples that I think will make it make sense. Okay, so let's just start with an easy one. Let's say that we have the integral of 3x squared. Okay? We're going to follow the rule. The first thing that you do is you're going to add 1 to the power. If I add 1 to this power, bless you, what's my new x now? X to the what? X to the third. Then what do I do with the 3? Divide it in the front. Now it's a 3 over 3. What's the 3 divided by 3 though? So this is really 1x to the 3 plus c. Okay, so let me walk you back through. Some of y'all look a little confused. That's okay. Okay, so I added 1, so now it's x to the 3. Then I divided by 3, and I got the 1 in the front. Normally, you wouldn't write this step, right? You just do it in your head. Okay, now, go backwards, check your work. What's the derivative of x to the 3? 3x squared. That means you did it right. Yeah? Okay, we'll do maybe like 2 more, and then we're going to get into harder ones. So let's... Yeah? Okay, so let's say that you have the integral of 12x to the 3. Okay? Remember, you add 1 first, then divide. So if I add 1, what's my new power? X to the 4. Then I have to divide by 4. What's 12 divided by 4 in the front? 3. So it'd be 3x to the 4 plus c. Then you're like, wait, I don't know if I got it right. Take the derivative. What's the derivative of 3x to the 4? 12x to the 3.
In the power rule, like equation numbers, why is it?
Are you talking about here? So it's because these had an... Okay, yes, so it's because here I didn't have a coefficient. This is like a 1x to this n. So here, if it's a 3x to the n, that changes to a 3. Okay? Alright, I'm going to give you one more. And then we're going to do some harder examples. So let's say that it's 6x dx. Okay, so there's not a power written, but we know what the power is. It's an x to the what? X to the 1. So remember, in this order, you're going to add 1, then divide. So do it. What's my antiderivative? Plus c. Very good. Perfect. Got it? So you're going to add 1, then divide. Add 1, then divide. Okay, I'm going to give you a couple of longer ones. Okay? So first one is going to be the integral of x cubed minus 12x squared plus x plus 4. Now, sometimes you'll see parentheses written around. Remember, this is called the integrand. It doesn't matter if they're there, cool. If they're not there, it doesn't change anything. Okay, so go one term at a time. You're going to add 1. What's the new power on x now? X to the 4th. And then I have to divide by 4. What was already there? A 1, so 1/4. Okay, next term. I have a 12x to the 2. Add 1, now it's an x to the what?
3.
X to the 3, but then I have to divide 3 by the minus 12 in the front. Now it's a minus 4. Next term, I have an x. Add 1, what's the new power?
X to the
2. And then I have to divide the 2 with the number in the front. What was the number in the front? 1, so now it's a 1/2. Okay, now let's talk about the 4. There's not an x there. That counts as kind of like an x to the 0. Okay, pretend like there's an x to the 0 written in. So if I add 1 to x to the 0, now it's x to the what? X to the 1. And then I have to divide by 1 on the 4, then it's a 4x. Plus what? C. Okay, now, if you're not sure, what do? You take the derivative, make sure that it gives you what you started with. So let's just go term by term. So this would be 4x to the 3, but then the 1/4 makes it just an x to the 3, then a 12x squared, then a 1x, then a 4x, then a c. Question?
If it's like constant, can you just put like the x next to it?
Yes, we're about to write that rule. Yes?
Do you have to have the parentheses taken before the sign?
You do not. You don't have to put parentheses at all. Okay, now, Yoel asked a good question. We were about to write in a new rule so that you don't have to think about it every time. Whenever you have the integral of a constant k, it's just going to be kx. So if it's a 5, what's the integral of 5? 5x. If it's a 3, integral is 3x. If it's a pi, it's pi x. Yeah? Good? Okay. Next one, we're going to do the integral of, let's do 3 over x to the 4 plus, 6 over x to the 2 plus 5. Now, I want you to think back to all the crap that we did first semester, right? The first thing that you should do if it's a fraction is think about, does it have to stay a fraction or can I rewrite it? Now, obviously in this one, rewriting is going to be pretty easy. Any terms on the bottom will come up, and how will I change the exponent? Okay, good. So I'm going to rewrite this to be the integral of 3x to the minus 4, 6x to the minus 2, plus 5. And now I'm going to take the antiderivative. So I want you to use the rule that you just learned. You're going to add 1, then divide. Add 1, then divide. So x is now to the what? If I add 1 to negative 4, negative 3. Then I have to divide negative 3 by the 3 in the front. What is it now? Negative 1 plus, next term, x was to the negative 2. Add 1 to negative 2, what do you get? Negative 1, but then I have to divide negative 1 into the 6 that was already there. What is it now? Minus 6. 5 is a constant. What's the antiderivative of 5 then? 5x plus what? C. Now on the AP test, they're not going to leave negative exponents, so we would convert that to be negative 1 over x to the 3. Minus 6 over x plus 5x plus c. Good? Okay. Next one. Integral of x times, let's do 3x plus 4 over x squared. Okay, for derivatives, you have all these random rules. You have quotient rule, product rule. Okay, there's not a product rule or a quotient rule for antiderivatives. So instead, you would have to do a rewrite to make it not a product anymore. So we're going to simplify this just by distributing. Okay? So looking at that first term, if it's x times 3x, what is that really? 3x squared plus, then I do 4 over x squared times x. What am I going to get there? It'd be 4x over x squared. Can we reduce that? That'd be what? 4 over x. So far, so good? All right, now I'm going to do a rewrite. So what will my x turn into here? X to the negative what? Negative 1. So plus 4x to the minus 1 dx. Okay, do your antiderivative rules for me. So remember, you add 1 first. So my x is now an x to the what? X to the 3. Then I divide that 3 with this 3. I get a 1. Okay, then I go to the next term and look what happens. I'm going to add 1 to negative 1. What do I get? X to the 0. But then I have to divide by 0 on the 4. Are you allowed to divide by 0? No, you have to use a certain rule. So whenever that happens, you have to think about, I'm going to give you a couple seconds to think about it. What function, when you take the derivative, do you get 1 over x for? Natural log. Very good. So the integral, I'm going to put a little star, special rule here. And you'll know that you have to use it because you'll get a divide by 0 when you do power rule and it gets all messed up. So the integral of 1 over x is ln x plus c. Now you'll notice that I put absolute value bars around the x. That's because you can't take the ln of something negative. Okay, so those just always go there. So the integral of 1 over x from now on, every time you see it, is going to be ln x. Now this is 4 times 1 over x. So I'm going to rewrite this as 4 times 1 over x. That's the rewrite that I'm going to choose because now I'll recognize that what's the antiderivative of 1 over x we said? Ln x. So then the derivative of 4 times 1 over x will be 4 ln x plus c. And that would be your answer. So whenever you see a 1 over x, you automatically know power rule is not going to work. Ln x is going to be your antiderivative. Okay? Alright, I think we have 2 more kind of like that. Next one, x squared plus 3 over x squared dx. Okay, no quotient rule for antiderivatives. Okay, what could we do to rewrite this? What strategies do we remember? Remember, you can separate them. So I'm going to do x squared over x squared plus 3 over x squared. And if I rewrite it like that, what is x squared over x squared the same as? That's just a 1. And then how could I rewrite my 3 over x squared? 3x to the negative 2. So remember, if it's just one thing in the denominator, then you're allowed to separate, reduce each term, and then do power rule. Okay, what's the antiderivative of 1? It's a constant. 1x. Okay, your x to the negative 2, add 1 to that. What are we going to get for our new power? X to the negative 1. Then I divide negative 1 with a 3. Now it's minus 3 plus what? C, always at the end. Now, could they rewrite that? I'm going to go ahead and do it, but you don't have to. You would do 3 over x like that. Yeah, those are the same. So it does not matter to me which one you do. If it's multiple choice, though, you'd have to recognize both. So remember that when you add 1 to negative 2, you're going to actually get negative 1 instead of negative 3 because you're adding to a negative. Yeah? Okay, last one like that. You can fit it. Okay, integral of 2x to the 3 halves plus 3x to the 1 half plus 6x to the 2/3. Okay, a little bit of fractions just to get us back into all that. So remember that when I add 1, I want to use a fraction, a unit fraction of the same denominator. So if this is a 3 halves, I want to add a 2 halves. Yeah, remember this? Okay, so what is 3 halves if I add 2 halves to it? That would be x to the what? 5 over 2. Very good. Now, when I divide by a fraction, I need to divide by 5 over 2. What am I actually going to multiply by? 2 over 5. So I'm going to have 2 times 2 over 5. Now, if you can put that together right now as 4/5, cool, do it. Okay, next term. I have a 1 half. I need to add 2 halves, because that's the same as 1. What is 1 half plus 2 halves? X to the 3 halves. But then I need to divide by 3 halves, so I'm going to flip and multiply by 2/3. Okay, you do the next one. It's in thirds. So when you add 1, you're not going to use 2 over 2. You're going to use what? 3 over 3. Very good. What is 2 over 3 plus 3 over 3? X to the 5 over 3, right? And then I have to multiply by the reciprocal, so it would be a 3/5 plus c. And then from there, remember the way that fractions work, you times the tops together, okay? Or if something's on top and on bottom, you can just cross it out. So what will my first term be once I combine the number that was already there with the fraction I divided by? 4/5 x to the 5 halves plus, next term. Okay, how did it become a 2? Well, 3 times 2 is 6, divide by 3 is 2, or cross out is probably easier. X to the 3 halves plus Next one. 6 times 3 is how many on the top? 18/5. And then x to the 5/3 plus c. Make sense? Okay, we're going to do a couple questions off your homework just to kind of get you started on it. Make sure that you understand the notations and that kind of thing. So, do number 7 for me. Okay, do we have a product rule? No product rule. What would we call it then if we need to fix it? Okay, distribution, or we're going to rewrite it. So, dy dx equals? What would it be? Okay, x3 plus 3x. Okay, now, the instructions are to solve for the general solution. So, you are going to take the integral on both sides. What did we say the integral of dy dx is? Just normal y. Very good. When you take the integral of f prime, you get f. When you take the derivative of dy dx, you get y. And then what's the antiderivative of x to the 3? Add 1, then divide. So add 1, what's the new power? X to the 4, then divide. 1/4. Okay, next term, it was a 3x. Add 1. Now it's an x to the what? To the 2. Then I divide 2 onto the 3. Now it's a 3/2 plus c. Okay, number 7, you're going to need to simplify as well. How could I rewrite that if they're all over x? Could I divide them each by x separately? I did mean that. Sorry, what did I say? Oh, sorry. What would I need to do? I would do, don't write this as big as I'm going to write it, but y'all know I write too big. That, yeah? Because we'd have to break it up and divide each part by x. So what is x to the 4th if I divide an x off? An x to the 3. Okay, next term. I had a 2x squared, but I have to divide an x off. Now it's a what? 2x. And now, am I going to rewrite a 1 over x? No, that's a special. Okay, so now let's take the antiderivative on both sides. So I'm going to integral. What's the integral of dy dx? What do we call it? Normal y. And then x to the 3, what's the antiderivative of that? 1/4 x to the 4th. What about minus 2x? What's the antiderivative of that? X would be to the what? The 2, right? But then I divide the 2 with the 2 that was already there. Now it's a 1. And then what about the 1 over x? Antiderivative is what? ln x. Got it? Okay. Now we're going to do a little bit of trig so you can do more of your homework. So what I want you to remember is that antiderivatives are derivatives backwards. Okay? So I want you to write your snow cone little ladder thingy. Okay, remember that when you're doing derivatives of sine and cosine, you just go down the ladder, snow cone, negative, negative. So when you do derivatives, you're going down the ladder. When you're doing antiderivatives, you're going which direction? Up the ladder. So if I ask you for the antiderivative of cosine x, you would start at cosine and you would go up 1. It would be what? Sine x plus c. Okay, so antiderivatives, you're going to go up. Okay, next one. What's the antiderivative of negative sine x? So if I'm on negative sine and I go up 1, what does that put me on? Cosine x plus c. Okay, one more example like that. Let's say that you're on normal sine x dx. That means I'm starting at the top of the ladder. If I go up, where do I end up? Negative cosine x plus c. Yeah? So instead of going down the ladder for derivatives, you're going up the ladder for antiderivatives. Now, there are a couple others that you should know. What is the derivative of tangent? Secant squared. Then what is the integral of secant squared? Tan x. Okay, think about y. If I start with tangent and I take the derivative, I get secant squared. Then when I integral secant squared, I'm going to get back to tangent. Now, I know probably most of you don't have your pink sheets out.
Sorry.
If you look on that pink sheet, okay, look on the back side. All your integral rules are up here. Okay? And so you probably haven't looked at this side much, but it has all of them on there, but you should know that they're the same rules that you already learned, they're just backwards. Okay, so for example, the derivative of secant is secant tan. Then what's the antiderivative of secant tan? Back to secant. So if you memorized those last semester, hopefully maybe you memorized some of them, then the integral rules are just backwards. Okay? So real quick off your homework, I want you to do number 11. Okay, 11 is the integral of secant squared. Look on your list. What's the integral of secant squared? Or you just wrote it in your notes. Integral of secant squared is tan. And then what's the antiderivative of negative sine? You just wrote it in your notes. Negative sine would be positive cosine theta. Okay, so if it comes to a trig rule that you don't remember, you're just going to go back to your list. Okay? Number 12, take a look at it. I'm going to put my list back up here. I want you to try it. You're looking for the antiderivative of cosecant cotan. It's on the screen. What rule is it? 17. What's the antiderivative of cosecant cotan? It's negative cosecant. Okay? So number 12 on your sheet, on your homework. Okay, I'm going to put it up here. What's the antiderivative of a constant 1? Normally it would be x, but what's our letter this time? Theta. So instead of theta, instead of x, I'm going to put theta minus. Now, quick point here. Cosecant cotan is negative. Cosecant cotan here is positive, but the answer is negative. So when I integrate this, I get negative cosecant, but there's already a cosecant in my formula. So am I going to put plus or minus on my answer? Plus. And then it would be cosecant theta. Plus c. Got it? I'm sorry? Uh-huh. Yeah, so it's technically a 1 theta. Think about like if it was a 3, the integral would be 3 theta. You're just switching out the x for theta instead. Okay? All right. And then one more I'm going to put on here as well. What is the derivative of e to the x? E to the x. What's the antiderivative then going backwards? Still e to the x. Okay, so remember that all of those are really the same. They're just backwards. Okay? So now we are going to get into what's called a particular solution. So all of the ones that we've done so far have been general solutions. Okay, a particular solution is an antiderivative passing through a specified solution. Or if you want to, you can put a particular solution, because that's where it comes from. So they're going to give you a point, and you're going to have to go back and find the C value. Now, in order to have a specific C value, they would have to give you a point for it to pass through. Okay? So we're going to do an example of that now. So let's say that your equation f of x equals, and let's say that it's 6x squared plus 4e to the x. And you want to find capital F of x through the point 0, 9. Okay, this is little f. I want capital F. Am I doing a derivative or an antiderivative? Antiderivative. So, put an integral sign on both sides. What is the antiderivative of little f called? Big F. Okay, on the other side, now we have to take the antiderivative of both of these terms. What's the derivative of 6x squared? 2x to the 3. Okay, now what's the derivative or the antiderivative of e to the x? Still e to the x. So it'll be 4e to the x plus c. Now, this is a general solution because we don't know the c. But if we have this point, we should be able to find it. So we're going to plug in, this is my x, this is my y, and we're going to find c. So it would be 9 equals 2 0 cubed plus 4e to the 0 plus c. But 2 times 0 is what? 0 goes away. Does 4e to the 0 go away as well? E to the 0 is 1. Very good. So really this is 9 equals 4 plus c, which makes c what? 5. Now, there are annoying things about derivatives, there are annoying things about integrals. When you find the c, you do have to go back and rewrite your solution. So we would write then f of x equals 2x3 4e to the x plus 5. This is a general solution. This is a particular solution. Okay? Alright, we're going to do one more, and then we probably won't have time to do any more. Okay, ready? Let's do f double prime of x equals 4x3 plus 3x squared minus 4x plus c. Find f of x given that f prime of 0 is 4 and f of 1 is 8. Okay, now if I gave you f and asked for f double prime, you would have to do the derivative how many times? Twice, right? And if I have f double prime and I want to get to f, I'm going to have to do the antiderivative twice. So, f prime equals the integral of f double prime, and now we're going to do it. So, if this is f double prime, when I take the antiderivative once, that's going to put me at f prime. Now, what is the antiderivative of this expression? Just go term by term. X to the 4, then I divide by 4, it's a 1. Okay, next term. Add 1 here, that's going to be x to the 3. Divide by 3, it goes away. My 4x, x is now squared. Divide the 4, that's a 2 plus, oops, there shouldn't have been a c there. Then from there, I have to go back and find the c. Will I use this information or this information? F prime or f? Which one do we have here? So I know that f prime of 0 is 4. I'm going to use that. So 4 is the answer when I plug in 0. And I automatically know then that C is what? 0, 0, 0, so C must be 4. Which means that F prime is x4, x3, 2x squared. Okay, because we're not taking a derivative, we're taking an antiderivative. And so this is why. We may not have time to finish. If we don't, we'll finish next time. But when I take the antiderivative, is that 4 going to matter? Yes, because what's the antiderivative of 4 going to be? 4x. So that's why you have to find it. We will finish this one next time. You can do most of your homework, but probably not the back side. Okay? And remind me, we do need to finish a couple more tomorrow. Good job. Sure. You have a question? Because your name. Okay, no, think about what is 1 over cosine. So 1 over cosine squared is the same as.
Oh crap, you're in my class.
I'm going to be 10x plus c.
Miss Joyner?
You fill out the top part, and then you cut it, so this is 2. So if you're only doing it for my class, you would only take 1. Yeah, so then you would cut it, and then you'll fill out the top part, give this to me, and then I give this to you.
And so I can do so like my AP English and Bio?
Yes.
Let's try to.
Yeah.
More, right?
Huh?
We got some more.
Yes, I'll get more.
What's up, Brendan?
Hey, Marty.
How's Callie?
Good.
Bye, Mark. Have a good day.
I worked. A lot, yeah.
Still work at Trinity Thing?
No, I quit.
Where are you working?
I work at Piata.
What are you doing? Dead ass?
Yeah, I've been working there for like a month now.
Yo, Marty, why didn't you tell me, bro?
I thought you knew.
Dude, you're supposed to give me updates, man.
You have
Sorry,
y,
bro. I like to
and then if you tan x.
Really?
Yeah, I've had clothes on.
Makes sense?
Fish place sucks.
Yeah, so
Is your friend still live there?
I applied once and then they denied it. I said, I'm not doing it again.
Will you ask Colton if he wants his folder?
okay.
I asked him over Remind and he did not reply, so I'm assuming that means he doesn't care.
His math folder?
Yeah. Well, I don't know if it's his math folder. I didn't really look through it, but I saw like pink sheets and stuff.
Oh.
So
Okay.
probably they'll burn in a bonfire, but
Yeah.
just in case.
Okay, hold on.
Do you have him in class today? Again?
No.
Oh, okay.
Bye.
Bye.